Hi, my name is Alessandro Langelosi and that's a video tutorial coming from cgcookie.com for Max Cookie. In this tutorial we'll see some tips, information about how to simulate something similar to a plasma fireball using a PFlow. We'll make just an introduction, so it will be useful for a future more complex tutorial to create the complete set with also the rendering done with Krakatoa and the compositing done with combustion or something else. The first thing, I checked the units and we set right. So we can create a sphere. Let's imagine maybe a 35 centimeter sphere. And I like to go for a wireframe viewport, and we can remove the grid using the G key. And then I will create another sphere, a really little sphere, let's say maybe 1 centimeters, and this one will stay inside in the middle of the second one. So this one will be let's say the energy center, and this one will be the plasma ball outer, or maybe just out. Okay, so it's a really simple setup, you see. And the first thing we need is to create a particle system, and we'll use particle flow, this one. So we'll set up a really simple thing using a particle flow. And we'll try to have it really fast and really simple. So the first thing, we say that we have the particles inside the scene at the beginning. Let's imagine maybe to have 8 particles. And we say to particle flow to use all the particles in viewport. So we have 8 particles. And then we have the position. The position will be on the little sphere there. So let's go there for a position object over the old position icon, and we'll say by least, and we choose for the energy center. Select. So you see we have the particles flying away from the center. We need to change the speed, so we don't need that the particles will fly away. And we'll try to use a speed by surface, and the surface will be the energy center. So we can go near this one, and you see that the particles are flying away from the center, and we say that the speed will be maybe 50 centimeters, that the speed control is continuously, so every single frame will be controlled by the speed controller there. And then we have to say the direction. The direction is parallel to surface. So you see the little particles are flying away all around the middle sphere there. Then let's go back to the speed. Let's try with 5 centimeters. You see it's really enough. Okay, perfect. So we have this this point there, and we can see as dots moving, and it's really nothing so similar to a plasma energy arcs. So let's remove the rotation. So right mouse button and delete, because we don't need it. And what we need now is to say to this point to create an arc. So let's say to have just one for the moment, so we have just 1 particles. To create the arc, we can, for example, make a spawning. So let's go to pick a spawn event, and let's put it there. Move on the other side. Sorry. Okay. Okay. We have the spawning, and we have to say how the particles will work, because if we say, for example, that the particles is spooning in this way, you see that we have just the ones and we have nothing. If we say per seconds, we have more particles created there. You see that we have particles there, but we need that, we need to control the particle there, and we have to say that this particle will fly away. So to move it, the most simple way is to have a speed. We connect this one there, and if we have the spooning, you see that the particles are going away. But we like to have the particles going to the sphere. So what we can do is to use the find target. You know that without find target, we can say to a particles to go in a point or to search for an object. So we can go there, and let's try to use the find target over the speed, and we say to find the objects, and we say the plasma out. So the particles will search, you see, for the sphere. Okay. Another interesting part is that we like, for the moment, to have just maybe a collision when we have, first of all, we need maybe less speed. So you see, it's not so fast. Okay. Then we can try to have, for example, there, let's see what happens if we have a spawn. And this time the spawn is by travel distance. Let's try with 10 centimeters. And let's say that we have 75% of speed from the first one. Okay, we have to tune it. But I'm thinking also to have a different setup. So we can go back to the speed one, that will be faster. So let's use the speed there. And we'll have there maybe 10. We can stay with this one, it's not so much. Let's say that we have a speed. And the speed will be, for example, we can use not so high speed. Let's imagine maybe 20 centimeters, and we have a long icon arrow, and we say instead to use a different setup. And to do the setup, we can move the icon there. So we'll move it there in the middle, and we say to use the icon center out. Perfect. So you see that the particles are going away in the meantime that it's moving. Okay, so let's go there, and let's say to use dots also this time. So you see that we have these particles going in this way. Let's use there a lower speed, let's say for example 2 centimeters, so it will be more controllable. You see that we can control how it looks. Okay. Now we can, for example, add more spawning in there. Let's see, with 50. Okay, you see that now the line is more stable. Obviously, you see it is losing detail there, but we can use an higher level. What we need is to have a noise over it. So there are two ways. If you have the additional node there as the boxes from orbits, you can use the random walk that give us a noise. In other case, we can use a wind. So let's go there. Let's create a wind, and then back. let's use select from scene the particle flow, and we go there and we say that this particle has a force, and the force by least will be the wind. You see that the wind now has the speed, and we say speed 0, and we'll try to add turbulence. Now we adjust to find the right scale. Okay, let's say to have a little bit more frequency. And a little bit more turbulence. Okay, and a little tuning to the scale. And you see that it seems with a noise. Okay, let's change again there the speed. Let's say maybe 0.5, so we have a really slow movement. So you see it is moving not so fast. And there, let's give us more frames. Let's try with 500. So we have enough frames to control it. Okay, you see that we have the right control and the right amount of quality there to control, but our rays, our particles are flying away outside the sphere, so we have to control this problem. And this problem can be controlled with a collision. So, you know, usually we can use the collision using the universal deflector and the collision condition there. But to be faster, if you have Krakatoa, you can use the Krakatoa collision. So please remember that you can do it using the collision with the universal deflector set to the sphere, or you can use the collision from Krakatoa. To be faster, we'll use the Krakatoa collision. So we'll have the collision, and we say that we have to control the collision with the sphere. Let's try, and you see that we have no collision. That's really simple, and that's because, okay, let's remove the animation because actually we have no animation. That's really simple because you see we have the collision check with the front face, and we have to check with the back face because we are colliding, you see, with the internal face, and you see that the particles now are colliding. But we have to control in a different way the particles that are colliding. So I'd like to have an energy collision with the environment there. So we have to control the speed, and the speed will be a speed by surface this time. So let's connect, and we'll have a continuously speed collection there. Let's say maybe 3. And the mesh will be the plasma out. Let's see what happened. You see that we have it colliding, and let's say that it is parallel to surface. So you see that it's expanding during the collision. So let's scale there to have a better control inside the scene, and let's scale it there, and let's see what happened. You see that we have particles colliding and then expanding. So let's try to see it maybe with dots, and we change the color to something really visible. So you see it is colliding and expanding, and I like to change a little bit there. So we have a collision speed by 3, let's say maybe 5 with a variation of 2. Okay, you see that we have a sort of expansion, and then we have nothing more there, and I like to have a little bit of we can have maybe a little bit less speed. Okay, and maybe we can have a little bit of spooning. So we should have, for example, also a spawning as we were saying before, and we can have, for example, by distance, let's try with 10 centimeters just to be faster, and let's say 75% with a variation maybe of let's say 30% and a divergence of 5. And let's see what happened. Okay, we have to use a lower value there. Let's remove the restart particle and let's try by 2 centimeters. Okay, it is working, but it's too much. We can use this one and let's say 45%. And I like just to see, maybe it can, maybe it's too much, so we can maintain for the moment this one set to off, because we will have also more particles later. So, and another thing we can use is to have less peak. So let's try with 1 and 0.5. Okay, you see, so we have just where it touch, and then we have a delete after a while. So delete there, and let's say when the particles are maybe, let's try with 40, is too less. Let's try 75. Okay, maybe a little bit more, 85. Okay, and let's try to have again the spawning. Let's have to 0.5. Let's try with per seconds. It is still too slow, you see. Let's stop it. I stopped the. Okay, let's remove again the spawning. That is too much slow. So we have this situation there, and now we can do is to have, we have the delete, and that's right, and we can have a little bit different. Let's see, the wind. So let's pick the wind there. Let's say to have a little bit more turbulence and a lower scale. Let's see if we have more frequency. Let's try with 0.5. Okay, it seems a little bit better. Let's go back there to trying to have, for example, 8 rays, and you see that we are starting to have the usual look as a plasma sphere with the energy when we have the collision with the sphere there, and we have to check there that it will be possible to have a more stable look using a rate for the spawning there by 150, and let's see what happened. And you see that the arc are more precise, so it is really better. Let's try to prepare a simple setup to have the rays at the beginning, and we have just to say that the particles will start at -30 and -30. So you see that we have particles inside. Maybe we have to say a little bit before, because we need the time to create it. So let's say -60 and -60. So you see we have the rays inside there. Okay. Obviously, it's really simple, because we can add, for example, another noise layer to have a more noisy effects over the arcs, but it's not bad, and we can change the color for this one to have it darker. Okay, so we see it's better. And let's do a preview, an animated preview, so we can check it together. Let's say 100%, and we need a wireframe, and let's create it. It will take not so much time. So we can see the preview together, and we can see if we have to fix something. And in a future tutorial, we'll see how to make a more complex and complete plasma sphere. And we'll see also how to render using Krakatoa and, for example, mental ray, the complete sphere with all the effects and all the other stuffs we need. We can wait maybe for just a part of the animation. We don't need all the frames. Let's wait. I'm writing what we have to do on the future part for the complete tutorial series. Okay, it is writing. Now I go. Okay, so that's the preview. It's really simple, but you can see that we have the plasma arcs moving inside the sphere, and we have complete control over the speed and the movements, and we can have energy over the sphere when the arcs touch the outer glass, and that's really interesting and really useful. So let's close the media player for the preview. So for the moment, that's all, and I hope to see you back on Max Cookie to check for new tutorial coming from cjcookie.com. Bye.